Dear participants of the International Workshop on Advances in Civil Aviation Systems Development, Lafayette, Day B, March 19th, 2025. Greetings from Air Transportation Management Department of the State Non-Commercial Company State University, Kiev Aviation Institute. My name is Andriy Goncharenko. I'm presenting the report on the topic of theory of subjective preferences entropy in application to air transportation technologies. It means rational recombination of resources. Dear participants of the International Workshop on Advances in Civil Aviation Systems Development, Lafayette, United States of America, Day B, March 19th, 2025. Greetings from the Air Transportation Management Department of the State Non-Commercial Company State University Kiev Aviation Institute. My name is Andriy Goncharenko. I'm going to deliver the report on the topic of theory of subjective preferences entropy in application to air transportation technologies. It means rational recombination of resources. As to the introduction, the literature survey shows the significance of the human factor and safety in aviation, and it's obvious that we have to deal with and we have to take into account the uncertainty of situations in some way. So it's proposed in this study, it's proposed to use the well-known James's principle interpreted in the sphere of psychological perception of alternatives rather than just working with the probabilities. So the problem setting and the problem formulation emphasizes that objective characteristics versus subjective preferences make a combination, a composition in the form of objective functional. And the main context of this research has the background as the subjective analysis, the so-called interpretation of subjective preferences based upon the individual perception rather than probabilities, that is, objective characteristics of the process, but probabilities and objective characteristics are for the external observer, but the internal participant of the process, it navigates the aircraft, for example, having the preferences, his own preferences inside, and bears active influence upon the system operation. So mathematical interpretation is proposed to be applied to the distance optimization. Let's say there are two aircraft that fly to the meeting point 1 and 2 with respect to with the respected speeds v1 and v2. So the distances covered also corresponding. The total distance is AB, and the distance covered by the first aircraft is AC. So, and here we consider this distance optimization. It's proposed first not to take into account the time of delay for the second aircraft. It makes the problem a bit simpler. So we have a criterion for optimization. It's the minimum flight cost, which becomes a function of the speeds of the aircraft. So, but in this notation. Formula number 4, this is the flight cost of the first aircraft depending upon the speed of the first and the second aircraft as the independent variables, and the cost becomes a function or dependable variables. And from here, it's not easy to find V1 optimal, and it's proposed here to use the parametric form of formulas 4 and 2 because they are interconnected. Well, and that yields the formula number 5, where we have this independent variable as the distance covered by the first aircraft. Now we deal with the human factor and safety system analysis, and these different types or points of meeting, they are alternative for the aircraft pilots. And generally, referring to the monograph of subjective analysis, this is the reference number 1, and the main supposition here is formula number 6. This is the objective functional that has a linear combination of 3 components. First component is subjective entropy that depends on the preferences functions symbolized as pi. It's not a ratio of the circumference to the diameter, not 3.14, but this is the designation for preference function. Sometimes even probabilities are depicted with the pi, but here it's the functional also entropy or measure of uncertainty of the Shannon type. The second member is the effectiveness function, which has the Lagrange uncertainty multiplier beta, and the third component is normalizing condition. It's the simplest member, just sum of preferences equals 1, and with the gamma weight coefficient or Lagrange uncertainty multiplier. But beta is very important here because it's a cognitive parameter that helps evaluate the significance of each component in this objective functional. And this is a functional, it means we need to find the function, the preference function, according to the alternative, the set of the alternatives taken into consideration. Next poster shows briefly the components of such functional and describes a bit the effectiveness function that depends upon preferences, and F, the so-called objective effectiveness, which is subjectively evaluated by the individuals, and that makes the system active when the active element, so this individual, a responsible person for making decisions, takes into account some objective characteristics in numerical form and can evaluate the situation through his own system of cognition. So formula number 8, this is the entropy of the Shannon style, but instead of probabilities, we see here preferences functions. Then the simplest way of the effectiveness function is just the linear combination. Again, objective effectiveness are weighed with the weight coefficients, which are preferences functions in our case. And the normalizing condition, formula number 10, the simplest one, it means the sum equals 1. So like for probabilities. The necessary condition for the extremum existence here, formula number 11, this is just the first derivative of the objective function with respect to each preference function equals 1. This vector gives the following canonical distribution of preferences, formulas 12 and 13. The 13, you see, it's more interesting because here we consider f function of effectiveness, not just some numerical value signifying somehow the value of the alternative, but here's the function depending on some parameter. And in this case, we may treat our preferences as the stimuli and perceptions with the correspondence to the main law of psychophysics by Weber-Fechner. And based upon the entropy approach, we may consider formula 14 and then respectively formula 15. We consider here stimuli S and perception P. So here in formula 15 we consider entropy of stimuli, the first member of the linear combination, and that yields, with respect again to the first order condition for the extremum existence, that yields the well-known Weber-Fechner law. So this is the main law of psychophysics. Exactly in this way, individual works with the alternative weights, loudness, brightness, and on. So it's a strong supposition, but it has its justification here because it's obtained upon the entropy principle. So taking into account the uncertainty of these stimuli, rather than first it was derived based upon some differential principle. In my report, I deliberately omit derivations, but in paper, the interested reader may find derivations of this law in both entropy principle and differential principle. Also, this notation coincides with the Jacob Bernoulli law for subjective price. Next, the result of distance optimization shown here in parametric form. So here we have speed of the first aircraft, and we find it optimal according to the criterion, the minimum of the cost of the flight by the first aircraft. So, but next step of simulation shows the distance according to the optimal speed. We may find the optimal distance. In such point, the research came to the end, and we may conclude that human factor is, of course, and safety system analysis, they are rationally treated in the combination with the functions of uncertainty or entropy conditional optimization. And presented problem here, make it visible, which was invisible in some simpler, even simplified form, but we did some sophisticated elaborations. We did it in a parametric form. We excluded the unknown parameter, for example, speed of the aircraft, and derived the formula exactly for dependence upon distance flown by the first aircraft as an independent variable. For further research, it's proposed and recommended to consider dependencies with some limitations and time dependencies, and promising is the set of variational problems. It's over. Thank you very much.